I'm not super quiet. We'll start at the beginning, I think. Why not? Cool. So here's the plan. Let me get a track of where the time is. All right, Andrew, if I'm going way too long, just tell me and I'll get to Q&A quicker. I kind of have the time visible, but it kind of blocks it. So here's what we're going to do. I've been doing some presentations recently about data lakes in Azure and how we do that with primarily Spark, and you looking at Azure Databricks and looking at Synapse Analytics. And so we're going to talk briefly about what those two things are. I'm going to talk a little bit about what Apache Spark is, not very long. And then I'm going to go through some demo stuff I've set up in notebooks. It's really kind of one main job that shows off some of the different Spark syntax, and we can talk about how it's going to run on the clusters. And then basically it's kind of open to Q&A about what you want to talk about related to all the other capabilities of the workspace and cluster management and things like that. So if you've come from running Spark in AWS or on premises or anywhere else, we can have some of those discussions in the Q&A and make a little more of an open conversation at that point. But definitely feel free to ask questions throughout. You can throw them in Slack in chat. I'm sure Andrew will jump in and help make sure I answer those before we get too far along. With that, let's keep on going. So I'm Dustin Vannoy, if we haven't met. Nice to meet you. Thanks for showing up. And here we go. So let's talk about the two things I already mentioned really briefly. So Azure Databricks is the service in Azure I'll be showing you for most of the time, because that's where I've got the main example and it looks very similar in the other system. And so Databricks is, and now I'm nervous because Lee's on, she probably got all the training recently and could tell me I'm saying it wrong. They probably changed everything since I last bothered looking at what their marketing says. So Databricks is a unified analytics platform. And so coming from a very data engineer perspective, I look at it and go, cool, it's managed Apache Spark. It's going to save me the headache of standing up open source Apache Spark and then figuring out what I'm going to use for notebooks. Is it Jupyter or Zeppelin, and getting that stood up and connected, and figuring out the security myself, and trying to figure out some different, like if I want to integrate MLflow, some of these capabilities that tend to come along with the Apache Spark cluster are ready to go with just really a few clicks, a few setup steps, pretty easy REST API or CLI to spin up clusters and that sort of thing. And so we're going to look at using Azure Databricks from the notebook experience, and it's probably the way a lot of people use it for ad hoc analytics. It's not how I do it day to day. We can talk about that towards the end. But the other things it offers, though, is it has performance optimizations. Databricks has their own version, their own distribution of Spark that's built to work well within their cluster. And so we have things like Delta Lake, which I won't talk too much about, but I'll use it a lot today. And they've got probably the most optimized, fastest version of the Delta Lake formats for us. And one of the things I think is amazing, and eventually this isn't going to be cool anymore, but I lived with it without it for too long, is auto scaling and auto terminate. And so if you've heard the Snowflake talks about what they do, and maybe you've been doing this all along on Spark for a while now, but basically I can spin up a cluster and say, hey, after 60 minutes or after 60 minutes, if nothing's been running on the cluster, turn this thing off. And I really appreciate that, because working with EMR right now, it doesn't do that for me. And if I turn it off, I have to go recreate it, which means I need to have scripts ready to go. With Databricks, I can do a bunch of stuff through the UI, which is really good for your ad hoc analytics and your testing and that sort of thing. So on the other side in Azure, this is the newer capability that actually includes a lot of things outside of the Spark and Data Lake territory, but I'll talk more about what I would use as a data engineer, not on the data warehousing side of things. So Azure Synapse Analytics, I kind of brand it as an integrated analytics service, which sounds really similar to unified. They kind of brought a bunch of capabilities of Azure. Azure is Microsoft's cloud, similar to AWS. Has the AWS cloud or the Google cloud. There we go. Sorry about that. So one of the things they brought in, though, that's pretty different is that they have Apache Spark pools that you can use within Synapse, and it's sort of coupled together, integrated with this capability called serverless SQL. So if you've been writing queries on SQL Server and you're used to their T-SQL flavor of SQL that kind of enhances standard SQL, you have ability to do that in a serverless fashion. So it's a little bit like Athena, probably even more closely like BigQuery, not trying to compare performance, but as far as capability, you pay for the storage you query, that kind of thing. So that's not Apache Spark, but that's one of the things that comes along with your Synapse Analytics workspace that's really powerful. And then we'll show you kind of how Apache Spark looks right now, and I'll talk a bit about the use case for it that's different than Azure Databricks. It's not quite as heavy lifting focused. And then that also has autoscale and serverless capabilities. It also has a lot of different things you might do within Azure built into that same workspace. You can integrate them other ways with Databricks too. This is just kind of one package deal. So for context, and I've used reference, it probably wasn't quite this pretty at the time, but I've talked about the reference architectures before and kind of ran through a couple of them. So the basic idea though, as a data engineer, especially is I'm going to build a data pipeline. We'll focus on to kind of load and transform data within a data lake. So within Azure, you're going to read from whatever sources you read from. A lot of times there's relational databases we use. Sometimes there's other cloud file systems we need to read from. Sometimes we're getting it directly from applications via some kind of streaming interface. And so on the top level here, what I'm indicating is that there's this service called Data Factory, which it is a no-code or low-code ETL tool. And so I could use this UI and build these data pipelines with it. What I'm going to recommend for that typically to data engineers is using it to orchestrate Azure Databricks jobs. Throw it in there kind of in place of where Airflow might be used to orchestrate your stuff. The capabilities are very different as far as like what kind of built-in connectors are there, but it's a way to make these, complex dependency graphs of your code run and trigger on a schedule and easy to restart and that kind of thing. So they also have on the streaming side, our data needs to go somewhere. Usually as a data engineer, it's Apache Kafka. AWS has Kinesis, Google has PubSub, Azure has Event Hub. So it's kind of our stand-in for Apache Kafka. The goal is we want to send all of our real-time data to one place, one message broker. This is a distributed message broker we're talking about. And then anything that needs to use it can go get it from that one centralized place. And so we've kind of decoupled all of these different flows of streaming data by using event hubs. And then the big heavy lifter then in this processing is going to be Azure Databricks, basically writing Apache Spark jobs that are using the cluster to do the processing, writing to Azure Data Lake Storage, which is a distributed cloud storage that's somewhat optimized for analytics and meant for these kinds of use cases. So if you're in AWS, you'd be using S3. If you're in Google Cloud, you'd be using Google Cloud Storage. In Azure, typically you're going to go with Azure Data Lake Storage. There are some different variations you could choose from there. So with Synapse, it's pretty much the same diagram. I just replaced a few icons. So ADF, Azure Data Factory on the last one, you can replace with Synapse pipelines. It's really the same code base, so there's not a lot different to talk about there at this point at least. And then Synapse Spark would be an option for doing the batch data processing with Spark, but they don't really, it's not a good system for streaming. It's not really meant for your streaming jobs, your streaming pipelines. And so Azure has something that's separate from Synapse, separate from Azure Databricks called Stream Analytics. And I think it's got some good advantages as to how it runs and sort of the model for paying for it. And you do it with this like SQL-like language, which is very appealing to some people, less appealing to others who are going to have to write these batch Spark jobs anyway, which is sort of the camp I fall into. All right, so that was the quick intro, maybe a little longer than I meant, but hopefully it helped give some context. Let's talk about Apache Spark. Basically, the thing you need to know if you're super new to this is we are going to do distributed computing with very simple code without thinking too hard about it. So if you like using pandas for doing data processing, but you think at some point one server is not going to cut it, one option is to go use something like Apache Spark, and you can now parallelize that workload across a cluster, do auto scaling and things like that, which are very helpful, especially in the cloud, and use a fairly simple API that might look like what you've used before in other libraries. So to start with, we're not going to teach you all the syntax, right? But I want to give you a few views as to what we're talking about with Spark. So this is the Python version of Spark. You can also do Scala, Java. You can now do C#, R. I think there's probably others. But basically with this PySpark version, if I'm doing a batch read, it's relatively simple once I've got things set up, which is also pretty easy once you get the hang of it. So I'd have a variable called df for data frame. It's very similar concepts to a pandas data frame, not, kind of like an R data frame, I guess. But basically, data frame is my object that's going to store the data, and I'll run a lot of operations on it there. To get that data in, I do spark.read. If I'm doing streaming, I do spark.read stream. That's kind of the difference between batch and streaming for connecting to your data sources. And then you specify a format. Quite a few different formats are used. We're going to look at Kafka today in this example, and I'll show some examples of reading from file. And then the options are going to be a little bit different when you're streaming versus batch, but you can fairly easily switch between switch the configurations out depending on which mode you're running in. So there's a lot of ability for code reuse if you're doing jobs that sometimes run as batch and sometimes run as streaming, which I found to be pretty common. I don't know how that is across all organizations, but usually there's some need to do it in batch as well as streaming. So on the writes, it's a similar concept, right? I already have this data frame, and then you call write or write stream. You specify the format, some different options like partitioning and destination paths and things like that you'll need to provide. But pretty simple API, especially once you get the hang of a few of these recurring methods that we're going to see. And then if you're doing aggregation, you can do things like group by, which if you write SQL, it's very similar. It just now looks more like a programming language instead of a SQL statement. One of the main things to know though is if you're doing streaming, you're gonna have to you probably are gonna think about windowing. I think this is an up-to-date example of windowing. I actually, there's a couple ways to do it, but the idea is that if I'm streaming, I'm kind of working with this always updating table. That's this continuous stream of data. And so I'm going to specify some kind of window of time that I want to do my aggregation by, because I don't really need to do average trip distance from the time I kicked off this job until now. I kind of want to look at something like a sliding window of last 10 minutes. So that is what I wanted to make sure we've talked about before we look at the demo. Any questions besides what does this look like? Not yet, nothing yet? Okay, cool. So this is an Azure portal, nothing special that I want to show you here. But if you've used them recently, it's pretty easy to find. But Azure Databricks has a workspace. From the workspace, you can go, or from the service, you can go down and launch your workspace right here, and you'll end up in your Databricks workspace. If you've used Databricks Community Edition or over in AWS, pretty similar, right? Not a whole lot different, a few different words, of course. And so what I'm looking at is I have a notebook in this workspace, very similar to a Jupyter notebook that you may be used to. I've done a little bit of Markdown to try and help us keep track of where we're at in the notebook. So what I'm going to show you is if I were trying to build the new taxi company that's like this blend of Lyft and a traditional taxi company, I'm going to need to analyze a whole bunch of trips data, a whole bunch of taxi trip data. The reason I like to use this example is you can go get this data really easily and quickly if you spin up your own trial of Azure Databricks. And I'll show you that path somewhere along the way here. And then the first command here that I'll show you is really just setting things up. I'm doing some imports, setting some variables, setting a date format. And then right here is something that's a little bit unique if you're not used to Spark. I'm setting a Spark schema, which is a struct type, and I'm adding all of the different fields with their data types. So that's all I've done so far. I'll go and run it again. I think I've done it recently. And with clusters that auto terminate, you always have to stop and see, is this cluster still running for us? Yes, it is. Cool. If it does turn off, by the way, and you trigger a job, it's going to take like 5 minutes to start back up in Azure Databricks. And so, you know, it's going to take some time. It's best to remember to do that before you need to go get a cup of coffee or something. So cool, it's running. And the first thing we'll look at is a simple example of loading up a lookup table. And so I'm going to go from a source CSV file, save it as a Delta format, which is going to be a more optimized columnar compressed format that's going to work well with Databricks and quite a few other big data tools. So in this case, my variable is called input data frame. I've got my Spark read that I told you about. Here's a couple of options in order to say that I have a CSV file, a delimited file that is, it has headers in it, and I want Spark to just infer the schema for me because there's nothing too crazy going on. Give it my path, and this is actually, this is actually the path out if you go and spin up your own workspace to public data that is already connected to your Databricks workspace. All right, so once I have that, I do a very simple translation. I'll show you more of these, but I do a with column rename just to get my naming standards in check. In this case, I do a write format of Delta. I just explained that is a good file format to use when you're working with Databricks in particular, but really with Spark in general, if you've got all the libraries ready to go. I'm going to tell it to overwrite and save and then display that for you. So this is going to take like a minute to run. We can trigger it. We have a little time, but I won't make you watch it the whole time. So that loaded up a lookup table. Now, here's kind of the core piece of this batch job. And then I'm going to show you this in streaming mode. So for the batch job, again, I'm just going to call it input data frame because I'm not very clever with my naming here. And then I'll do a read. I'll do it from a CSV file. This time I have a wildcard in here. So the asterisk here is telling me I want to get all of the 2019 data. And this is kind of your hint that if you're not used to data lakes and distributed systems yet, like a lot of times we're reading data that's actually multiple files that are either in a folder or we're addressing via wildcard. With that though, I'm going to end up reading, instead of like the 200 records I did before, this is going to be, I think about 85 million records, something like that it's going to process. This one takes more like 5 minutes, so I won't make you watch this run. And then for the transformations, we have two different options here. So you'll notice I had one of them commented out because we don't need both at once. So we're going to set a new data frame, which is just the result of this transformation. The way we do a lot of our transformations, one option for doing them in Spark is doing with column. And so we're working on a column at a time, much like pandas, similar to what you would put in like a SQL select statement. And I'm using some functions that are just Spark functions that usually they're named about what you would think. If you search the docs for the name that you would use in any other programming language, you'll probably find what you're looking for and figure out the parameters. And so we're able to basically take a string and do some replacements and convert it to basically convert it to a year-month string that I can partition on. I can convert to date, not too crazy and surprising, but this is how you do it in Spark. And then simple calculations this is not going to be an aggregation, by the way. This simple calculation is just showing that your normal operators like divide and multiply are all kind of what you expect in a programming language. So the other way you do it, that's actually in this case probably going to perform better. It may not matter for this example, but it can start to, the performance penalty can add up quickly, is instead of doing with column, which is going to have like a projection at each level and gets in a pretty crazy explain plan if you do too many of those, we could do one select expression statement. And basically, in this case, I'm doing it as if these were statements in a select clause. And so I select star, so I have all the records. And then I do just a different format, an expression format of writing out the types of transformations I want to do. And then I'm aliasing all the fields with the exact same names as I did in the other statement. So two different ways to transform the data. Once I've done that, I'm going to read in a lookup data set that we just looked at earlier. And then I can do a join. So my join is going to default to inner join. I've specified that it should be left instead. And then I'm going to tell it how to join this data. In this case, I have two different fields for the same ID, so it's pretty simple. I can drop extra columns at the end, do any renames I want to do, and voila, I've got the data frame that I want to write to my data lake. I call one thing that's different than what we saw earlier is I can partition as I go in this write statement. If you're new to data lakes, you need to know that partitioning is super important. It's kind of replacing indexes for you. So you want to think about that with a data set this large. In this case, year month was a pretty good setting. So threw that in there and saved it to a variable, a path variable that I said earlier. Any questions on what the heck I just showed you before I show you it in streaming mode? Okay. Hey, look, my lookup table from earlier actually loaded really quick. Guess I could have hung out and let you see that live, but that's okay. All right, so streaming, we'll get this thing running for us. Let me kick off the producer here. Cool. So streaming, I got a little bit of setup to do to hit event hubs instead of a file system, but don't get too caught up in that right now. If you need to do this, if you want to use event hubs with the Kafka APIs, which is what I'm doing here, this is a great example. It's on my GitHub. Go check it out. Ping me if you don't have the link. I thought I had in this workbook somewhere, but it may not be in this one. So you do a little setup. It's not too hard once you learn the Kafka shaded path and get the right SASL settings and all that fun stuff. Once I've got my setup though, I'm kind of in a mode that looks really similar. I'm going to do a read stream instead of read. I'm going to pass in all those configs I just set right here and call load. And so Spark is lazy evaluating, which I don't think about that much, but basically it's building up this query plan. And then when I call something like a write or a display or a count or an aggregation, some of the aggregations, it's going to start to kick off and run this query that I'm building up. And so load isn't actually kicking off anything yet. It's just telling it that this is where the reading configuration stops. And now we're going to get into transformations and things like that. So I take that input. This is a very magic line of code, in my opinion, that you don't need to memorize. You should remember to come find this, come find me, come get it from my GitHub if you need to do this. So if I'm reading out of Kafka with Spark and I'm sending JSON data, then I basically need to take the bytes that are part of the value field in the Kafka record I get, cast it as a string, apply some sort of schema with the from JSON function, and then give it, you can give it some kind of alias to make it a little easier to work with. Once you've basically gone from bytes to some kind of struct that is understood by Spark, you can then do select field name.star, JSON.star, and now I've just basically expanded that out into one column per attribute in my JSON dataset, JSON record, really. All right, once I've done that, I can start to do some renames and some conversions. You may notice this part's a little different, right? Because we're working with JSON data and not the delimited data as before. But once I get past that, these with columns, this is identical code. I just copy and paste it from my batch job, which if you're thinking about this and, hey, if I'm going to build a real project here with Spark, you're probably going to find that you have, shared libraries of common transformations. Maybe you're abstracting your sources and able to switch between like a batch and a streaming mode fairly easily without every job having to be completely different just because it's streaming versus batch. So for me, that's something that's really powerful about Spark that you don't always get. Let's run this guy so I can show you some data flowing in a moment. All right, then right at the end here, I read my lookup data with the exact same command. So this is a kind of a batch read, a static data set I'm building. And then I do my join. The join looks the same. There's a few things to think about when you're doing streaming joins, but since the lookup isn't going to change, since the lookup table is static, it's really not too hard. I changed the syntax slightly. I think that was just me playing around, if I remember right. Okay, so that's all. Nothing's happening yet. I just built up this whole plan, all my different variables that I set as I was creating different versions of this data frame. Now I can kick off the piece that's going to, you know what? Let's not write it. Let's display it straight up. I think that'll be a little more convenient for us. Okay, so when I run my display here, I can see that I do have data flowing. I think you're going to see that I'm not making this up, that I actually have data flowing right now all the way through Event Hubs into Azure Databricks and then being displayed on a notebook, which is not what I normally do, of course, but it's a little more exciting than showing you it writing back to Kafka and going somewhere else. Come on, demo, work with me here. All right, it'll do it. Trust me, it'll do it. The other thing I'll show you while we wait for some data to spit out is, this one's a little messy, sorry about that, but basically you could actually write to Delta, which, oh no, it may not do it because I have my write stream in there. I meant to have the display in a different spot, my bad. So I'm writing to Delta, so this piece might actually work. I can do like a reading stream out of the Delta format. So I'm streaming into a file format and reading out of that file format, which it's a little bit interesting. It's not reading back out of it, in a stream isn't something I do normally if it's not like a demo or a test case, but it's something that's pretty cool about Delta that isn't really a good idea with other formats. All right, one of these is going to show us data. It has to. There we go. Check it out. So one of the fun things if you're going to like present something you've done 20 times is to just change it a little bit right before you demo. It makes things way more interesting for you. So sorry about that, but we found our data. And I want to kind of move on so we can then talk some questions and stuff before we move on to group discussions. So the other thing I want you to see, I'll start with this one for you. So that was Azure Databricks. I did batch and streaming with Spark. If I come into Synapse Analytics, which by the way, I got here in a pretty similar way. I think it's slightly more hidden. You get into your Synapse screen, Scroll down to somewhere in the middle and do Open Synapse Studio. You'll end up right in a screen kind of like this. Come to my develop section and I'll see a bunch of notebooks that I've done, scripts and notebooks. Open them up, and this right here is basically the same code, same PySpark code running over in Synapse. And so if I were to look at this closely with you, you would see that the paths change. I'm pointing to some data lake storage paths directly that I'd kind of mounted and abstracted before, but the code's pretty much the same. If I come over and want to see it in .NET though, which is what I want to show you, because not a lot of people have seen this and it still kind of freaks me out to look at it. I can write Spark code in .NET over in Synapse. It's not something that you find like ready to go installed on probably any other managed Spark instance, I'm guessing. And so if you are really into C# and expect to do a lot of stuff that's not Spark specific, this might be something that comes in really handy. And so the main thing you'll see, you have to new up some objects instead of using some easy add methods like before. Main thing you'll see is that my method names all start with a capital letter, which seems very crazy to me, but that's how it goes. And if I were a true C# person, I'd probably change my variable names, but who really cares about that right now? So this thing processes, and I kind of want to tell you more about Synapse, but I don't want to waste too much of your time. So probably the thing to know is this one took like 7, almost 8 minutes to run. My other one took about 5 or 6 minutes to run. By no means is this a true test. I think that I've got different size clusters and everything happening. But so far what I've seen is like, if I think I can do it in Spark and it's not a streaming job, it's fairly simple, I'm not adding new libraries beyond what comes baked into Synapse, then I can probably do it pretty much the same pretty quickly over here. And one of the benefits of it is I could also switch over and use any tables and things that I register here. I can use those from a serverless SQL notebook or script, I should say. I think they call them scripts instead. Here's kind of a quick view we can look at. You have this option to reach out to your storage system using open row set, and from there I can do all kinds of things in the select statement that you'd expect from a T-SQL statement. So I'm reading Parquet data from this demo ADLS data source I set up. You can then create external tables on top of it. Same thing you can do over in Databricks. I just didn't show you that piece of it today. And then this yellow trips detail table would be available in both my Spark notebooks and in serverless SQL. So it kind of lets you start thinking more from an analyst view here. It starts letting you use multiple tools to query the data in your data lake and other linked data sources. People can choose between Spark and T-SQL and bounce back and forth in that way. The other thing to note, just because I mentioned it, I figured I'd show you the super basic, I didn't even bother naming this thing. Synapse pipelines, remember I said this is the same as Azure Data Factory. Tons of different activities or transformation types you can choose from here. All I'm doing here, which is kind of where I typically might use it, I'm calling a notebook. So I'm calling the same notebook I just showed you. If I go to settings, I think I'll see it. Data lake load.net. If I wanted to give it the chance to have parameters and all that, cool, we can do that. And then I can trigger, I don't know if I can trigger it now, but you can trigger this thing and have it run in the background and schedule it for a certain time of day, which is this piece here. It gives you all their scheduler capabilities if you're configured, which I really don't do anything with the Synapse pipeline, so we won't waste our time there right now. Yeah, so you can see like if you're in the notebook view, a lot of similar things, but there's actually quite a few more Azure capabilities here, including like more of a data warehouse, something that's more comparable to Redshift that's here in the same workspace. So where that leaves us is if I'm doing this stuff in Azure, if I'm doing querying and ad hoc stuff, doing things that really make sense to have in a notebook, which is not my typical day-to-day, honestly, then really either one has a lot of capability for me. If I'm trying to schedule jobs and have some kind of streaming job that's running all the time, that's where you start to see that at least at this point, I'm thinking for a while, if not forever, but for a while, at least we'll say, Databricks is going to do that heavy lifting for you. It's very much focused on running Apache Spark well, being performant. And it's just set up now for you to add custom libraries and do things that you would expect to do on a Spark cluster that really aren't meant to happen in Synapse, at least at this point. You kind of have to, feels like you're kind of working through a back door to get your own libraries up installed and things like that over on Synapse at this point. But it does have version control now, which is fun. I set this up today and I can actually use version control with my notebooks, which is pretty cool. And you can do that kind of thing from Databricks too. So yeah, with that, the other thing I wanted to say is that right now Synapse does not let you connect from your IDE. So I use PyCharm or IntelliJ all the time. And so I build up libraries that use Spark code. We deploy them to a cluster, and then we have some kind of job that we call, usually through a REST API, that will run that code that we've pushed up there already. That kind of thing, we're not really there with Synapse Analytics at this point, but Databricks supports that really well. So there's a thing called Databricks Connect if you want to get going with Databricks and do really more data engineering, building libraries, working from your IDE. Databricks Connect is a quick install that will let you connect from quite a few different tools that you may choose to use. All right, with that, we can discuss a little bit if there's any questions. What do y'all think?
Dustin, one thing I want to mention is within the notebook, what I like is within the same notebook in Azure Databricks, you can switch languages, different commands. You can run Python in one command, SQL in another command. Sometimes when we build pipelines, our transformation required a lot of, let's say, calculation that are based on the same columns and sort of like a set updates when the logic, it's easier to update as a set, where you have Windows function mixed with calculations, mixed with renaming. So technically you can have one command that in a language that does the best, Scala or Python, and then you can have another command, you just, the same way how you have it exactly %sign Python, you can say %sign SQL, and then create a temporary view exactly. So if you, and then in the next command, go back into the Python and process that temporary view, mix and match.
Yeah, and so I've had some stuff where the team was doing Python, but the library, I don't think supported Python. If so, there were no examples out there and I wasn't figuring it out in the time I had. And so we basically do half the notebook in Python and then switch over on the right. We'd just write it to probably a Delta table, maybe to just a straight up Databricks managed table. And then we'd switch over to Scala, read it back in, which is usually a pretty quick operation if it's a normal size data set, not a huge one. Read it back in and then do bulk writes to SQL Server, which didn't really support the Python API well. So yeah, switching between languages here is pretty powerful. You can actually switch your default language. So this is a Scala notebook with the same code that I had before. So if you haven't seen Scala, now you have. It's with Spark, it's not that crazy. Val in front of everything. Some of the commands change slightly. Really, the schema is the big one, but it's not that exciting. I changed from struct type with parentheses to this, and that was working. Yeah. So Spark has some really cool, Scala has some really cool capabilities in general, but also with Apache Spark specifically. That might be a reason why some people want to work in Scala, some want to work in Python, and every once in a while you might have to mesh that code together in the same notebook or have other reasons for doing that.
Oh, so it's like using multiple languages in the same notebook, in the same session while it is running?
Yes.
Yep.
Yeah, you can even
the variables are not. Go ahead.
You can even, sorry, Databricks representation here.
Yeah.
Yeah. If I haven't met you guys, I've been part of this group for a while, and I just joined like 2 months ago, Databricks. So I'm not trying to sell it. I was a huge fan, and now I'm actually working for him. Yes, exactly what he's saying. You can get into the bash shell as well. I was helping a customer today, and there's the like I was running netcat, right? Like the command right here, just so we could test connectivity somewhere else. So it's really cool.
You can change your host file right from here.
Yep. We call those magic commands, % whatever.
Yeah. We use a lot mix of Python and SQL when processing, when it's easier to do in SQL, where in the other language, it requires multiple hops. Then we do it in SQL and then jump back into Python when the processing makes more sense in Python or Scala.
Yeah, so what could be a practical example where I want to switch between, say, R or Python or Scala? Right?
Oops.
So could it be like APIs are supported in one language but not in another, in the same version? Is that one reason?
That's my main use case. Anyone else have other thoughts on that?
I
Yeah,
mean,
yeah.
go ahead, Lee.
No, you go.
I mean, I was just going to say language familiarity. There'll be another one, right? If you have people that they don't know Python, but they know SQL and they just want to do SQL, that'd be another reason to do it. Like some of the magic commands, like some of the file system commands are just super convenient to do for like moving files and things like that. So if you're like, I'm going to read this file and then after I want to move it, that those are simple to do with the kind of magic commands. Those are some of the other things that I could think of.
Yeah.
I'm not sure, Lee, did you have any other
No, you
use
said-
cases
you
for it?
said it all. Yeah, you said it all.
So I work with a team that have a lot of SQL background, have some different backgrounds really. But there's certainly times where, and this is true for me too, where there's something I'm like, I totally know how to write this in SQL. And especially if I'm just experimenting, I'm not planning to like save it and run it as a job, which is usually what I'm thinking if I'm in notebooks. I'm not really trying to make a job here. Nothing against that. It's just not how I typically do it. And so I'm like, oh yeah, let me just switch over to this cell, do some experimentation in SQL. Once I get my head around it, I can start to see if I can get the same results out of, PySpark or Scala Spark, whichever one we're trying to use.
And here's a question in the chat, Dustin. I don't know this. Does Synapse also have I assume polyglot language support within the same notebook?
It certainly does, yes. It does. Any other questions? I'll see if I can show it. Now I'm hoping I'm right about this.
I'm sure they were inspired by what Databricks did, but they didn't copy anything.
Yeah, I think when you build notebook functionality, there's a certain set of expectations across the board now. And so if Jupyter and Zeppelin do it hands down super easy and you don't do it, it's kind of like, what are you doing? And so, and it's had a few of those things along the way. I'm not sure, Andrew, if you got super hands-on with it, but it's had its things where like, where's the magic commands? Where's this? Where's source control, right? And they're getting there. They're adding stuff as they go. Now it's where's Spark 3.0.
We're all just trying to compete with each other. Like we recently announced, like we have our SQL Analytics workspace now on top of it and pipelines. Like it's feature for feature race with all these tools,
Yeah, I haven't got hands on with that one yet, Lee. I want to, but got kind of preoccupied. So this might be Python. I don't know why there's a semicolon in there. Oh yeah, C#. That's my other reason to use C# is if you really love semicolons and you hate having errors because you forgot a semicolon, then switch over to C#. You'll get some of those fun errors. Yeah, it looks like it understands that I'm trying to do Python here. It would have blown up pretty quick. So another thing that's probably worth mentioning since we're still talking about it is with Synapse Apache Spark pools, you're defining a size and how much you like resources you actually want to use per pool. You can have multiple of them, but it's going to go grab those things and spin them up when you kick off your job, meaning it's not something where you go and start up your pool. You go kick off a job and then that pool will stay active for a period of time. And so if you're used to Databricks, the options you get here are a little bit stressful because you have 3 sizes to choose from. You can pick auto scaling. And then ultimately, when it's time to use it, it's going to go spin that thing up. I don't know what I'm in now. Let's get out of here. When you go to use it, it's going to spin up the nodes that it needs. And if you're using all of them with one notebook and you try and run other stuff, it's going to go, well, too late. I've already used up all the resource and you got to go pick a different pool. So it's a little bit different model. Again, right now for analytics, it's pretty cool, especially since it comes, alongside serverless SQL and things that would probably be more of the driver for using Synapse right now. Any other questions or thoughts on this topic? Anything I said straight up wrong, y'all are welcome to correct me. Hopefully most of you know me enough to. All right, cool. The other thing that's really cool that I glossed over is using event hubs with the Kafka APIs. I really love because I didn't want to learn a different way to interact with a streaming broker. So it was kind of nice to go, all right, yeah, I can use basically platform as a service that's baked into Azure instead of standing up Kafka either on my own or with Confluent Cloud or something like that. So I find it's a little bit easier than like manage Kafka in AWS, but I also had people set up the security in the real environment. So that kind of makes it easier. This one's not super secure, so it's pretty easy to set up. Yeah. All right. Last 3 seconds, then I'm closing the notebooks and no more questions on them for the moment.
I didn't notice, but did it run and process the millions of records?
I didn't do the million. I did it earlier today, and so I'm in the wrong. That's the streaming. No, that was it. Did I save it from earlier? So it doesn't tell me the count because I did a display. Where did I put it to? So I didn't do that live because it does take a good 5 minutes or so on building that out. I have another one that does a bunch of like SQL queries against it just to kind of show some of that timing, because it's once it's in this Delta format, the timing's a little more bearable for a demo. But yeah, I ran this earlier today and it built that up.
Yeah, so I think how is Koalas coming along? Which is relatively new, probably a year and 15 months, a year to 15 months.
I heard positive, but not quite there things about it. Like it's not like going to cover everything, but I heard positive things recently from someone I trust. I can't remember who that is. I don't know, Lee or anyone else have insights. Is Koala's ready to go, or just for fun?
I'm not quite up to date on the current release. I think it's now on version 1.4, and what I've heard is that it's about 85–90% coverage of the Pandas APIs.
Yeah, I don't know much about it. I just know that you can. I've seen it in use just by importing it. You can same like we were going over earlier with those magic commands like he's doing. You can just do a %pip install on your Databricks notebook. So I've seen people install the Koalas library in that way and use it.
Nice. There's lots of fun stuff with cluster management, by the way, that you aren't going to get. I don't think you're going to get from Synapse. Oh, I don't have anything cool set up. Well, it's kind of lame, but you can do Spark configs and environment variables and all that here. Like in other services, you can set up, you can init the clusters with certain things and get all your installs done each time it spins up the cluster, rather than having to go and like remember to do it manually and that kind of thing. And you can install libraries right here from PyPy as well, which I like, though I guess the pip install is pretty handy too, huh?
Well, it's having one attached to the cluster, so you've always got the right library on the cluster. But for a use case where I want to spin up my own cluster and do some testing on a specific library and not mess up my other users, it's nice to have those notebook scoped pip install ability to just the person.
Oh, that's just at the notebook.
That's the beauty of it. You could do it here at a cluster global level, or when I'm just working on my notebook and attached to a cluster, it wouldn't coincide with someone else's library.
That's cool. I like that.
Yeah.
I might start doing that. All right. I think we're ready to move on to topics then. If you have any other questions that you think of on this topic, throw it in the chat and I'll try and answer it in chat as we go. Do you have the link handy again, Andrew, to make sure people get there?
Yeah, I can drop it in there again.
I gotta go kill some clusters because I'm already paying enough money to these cloud providers.
You're paying for Lee's Ocean View back behind her there, you know?
I ain't paying that much. But...
All right, so there's the link to the Google Doc. We got some topics in there so far. All right, I'll go share real quick just so everybody can see. Hopefully you're seeing Google spreadsheets right now.
For the two that posted your looking for job info, you okay with me sharing that in our Slack channel? I can move that over there for you if you don't mind. Just Alex and
yeah, totally.
All right, cool. I'll throw those over there and get them out of this view for us.
Yes, thank you.
You're very welcome to join our Slack channel, but if you don't sign up for it right now, that's okay. We'll still get your info out there.
Yeah, I added already.
All right. Anybody else adding topics or want to add topics? Okay, and I'm gonna assume here for Bobby and your Alex, looks like you're both kind of similar topics. One switching to data scientist, and one going into data engineering. It looks like so. We can either combine those or keep them separate. We can keep them separate for now. Just kind of see where all the kind of votes go. So if I go ahead and kill these rows. She'll just move this one up there. Maybe. Okay, well, we'll just leave it there. Okay, we got another one dropping in here.
And if you're new, don't be shy. You don't have to know any answers. It's more about discussion topics you think could be fun. So if you know
Yep.
everything about a topic and you really want to show it off, you can put it in there. But usually it's, hey, I want to know more or hear other people's experience with something. That's what Andrew's doing with his data catalog. Let me show off how much I know on data catalog.
All right. All right. Well, let's go ahead and vote then. And I actually wanted to, sorry, I was going to stop the recording.